In this video we're going to look at the confidence interval for a mean. We're used to finding the confidence interval for a population proportion. Confidence interval for a mean is slightly different. If you're unsure of this, maybe look back at the central limit theorem, okay, first of all. But to find the confidence interval of a mean, basically what we'll do is we take a sample from a population, we check its mean, and based on our sample we look at what the real mean of the whole population might be, okay, to a 95% confidence interval. Here's the system we use. Okay, so what I mean by this is the real mean will lie between the mean we get plus the standard error and the mean we get minus the standard error. So if we look at this question, it'll probably make more sense. So a random sample of 400 oranges was taken from a large consignment. Right? So we take 400 oranges, but there is a large, I suppose, a population really of oranges, or a large consignment of it, with an unknown mean. So we don't know the mean of the large consignment. And the large consignment has a standard deviation of 15 grams. The mean weight of our sample was 81.4 grams. Okay, so we take the 400 oranges and we see that there's a mean of 81.4. We don't know the real mean of the overall consignment, and that's what we want to find. We want to find the 95 confidence interval of the mean weight of oranges in the whole consignment. Alright, so we set up this. So the real mean will lie somewhere between the mean we get plus 196 with standard deviation over root n, and then the mean we get minus 1.96 standard deviation over root n. Okay, first of all, I want to find out what this standard deviation over root n is. Okay, so I'm going to calculate it. Alright, so let's do that over, let's do it over here. Okay, well, we know that the standard deviation is 15. We know that root n is root 400. We type that into the calculator, we get 0.75. So now we can set up our confidence interval. So the real mean will lie between, well, the mean we got, which is 81.4, plus 1.96, 0.75. And we have 0.75 here, minus 1.96, and the mean we got was 81.4. So working from that, we have 81.4 plus 1.47 when we multiply the 0.75 by 1.96, and we have our 81.4 minus 1.47. Bring this over a bit. 81.4 minus 1.47. So the real mean lies between 79.93 and 82.87. Okay. I'm saying x is the mean, okay? But often we say we have the mean denoted by this symbol as well. Okay, so x is fine, or we can write it like this. So, interpreting my results, what does that mean? Well, the real mean of that consignment will lie between 79.93 and 82.87. Okay? And that's to the 95% confidence interval, which means if I take a mean, if I take a sample from the overall consignment, well, 95% of the time the mean should lie between this and this. Okay, so that's it, guys. Thanks.